Hey everyone, welcome to Dev Summit. We are excited to be here. Today we are going to talk about give your CI/CD pipelines an ARM-powered boost with GitLab and AWS Graviton2. My name is Pranay Bakre. I'm a principal solutions engineer here at Arm, and I'm joined by my co-host Darren Eastman. Darren, why don't you introduce yourself?
Hey, thanks a bunch, Pranay. Hi, everyone. Darren Eastman. I am a senior product manager at GitLab. I specifically have responsibilities for GitLab Runner, which is the build agent that executes your CI/CD pipeline jobs with GitLab.
Thanks, Darren. Okay, so first we'll talk about what GitLab is, just as an overview. We'll talk about GitLab reference architectures, then we'll talk about GitLab Runners, CI/CD pipelines, and then we'll get into the performance analysis part of it and how we did the analysis, what kind of tools we used, and we have a lot of good things in store for it. All right, so Darren, I'll go to the next slide so you can give an overview of GitLab.
Yeah, hey, thanks, Pranay. Yeah, so for folks that are looking at this, and while we wait for Pranay's second slide to come, oh, it's up. I'm just going to touch briefly about what is GitLab and kind of what, how that plays into what we're going to discuss with terms of ARM and CI/CD execution and efficiencies and all the good stuff that we'll talk about as we get into it. But, at a high level, just kind of stepping back, here at GitLab, we have this concept where we talk about the fact that, every company in the world these days, right, or most companies in the world, they're really trying to become a software company to survive long term, right? And the way for companies to ship software faster and more securely, as we've kind of all been hearing for a number of years now, is DevOps, right? And we've all heard that term. And when we look at this slide, when we think about GitLab is really providing for that DevOps ecosystem, an end-to-end platform as a single application for any company to help them achieve the promise of DevOps and achieve their business goals, especially in this very competitive landscape that we're in. And so I'm not going to read through the slides, but basically kind of think about GitLab is that today, if you're using multiple different tools to manage project management, software configuration management, CI/CD, issue tracking, security, dependency, at GitLab, we give you one tool that helps you accelerate your move to DevOps and continuous integration and scale. So that's kind of what GitLab is in a nutshell. And the next slide, if you want to just pop up the next slide, Pranay, just kind of briefly talk about a little bit more in terms of the GitLab stages and kind of how that fits into, again, what we'll chat about as we talk about, the Arm and Graviton2 and all of the very interesting stuff in terms of compute. And so now we talked about a high level what GitLab is, and here we're just breaking down some of those stages in the DevOps lifecycle. And just kind of to paraphrase a little bit, another kind of a very interesting comment that I heard, or actually I read a few months ago, very similar to that theme I just talked about, right? Every company is trying to, and I quote this, is trying to figure out on how to become a software company. And I think another interesting observation I read as well, which I think is an interesting and potentially truism, right? And Pranay, you can jump in here and tell me if you disagree, is that, cloud computing, and I know cloud computing is an overloaded term, but bear with me, right? Cloud computing has really shifted the value of software. And it's shifted the value of software from the code itself, in a lot of cases, right, to the ability to deliver that code reliably at scale. And it may fit for a number of different organizations. That paradigm, some organizations are getting there, but I think generally speaking, that's what we're seeing with a lot of Arm customers and that we're dealing with, a lot of customers on GitLab CI/CD. And so what this slide is trying to at least encapsulate is kind of thinking about how all of these stages in a DevOps lifecycle fits within GitLab, and the fact that as you adopt GitLab and then some of the capabilities and flexibility that GitLab has, such as we're discussing today, the ability to, in terms of supporting ARM chipsets and so forth, is that you can get 200% faster DevOps lifecycle with a tool like GitLab. And then really fast, well, my last slide, I kind of want to chat about kind of introducing and setting the stage. So yeah, Pranay, you can click on the next slide for us. Next slide is all of the different stages that we have here at GitLab. The stage that I'm going to drill into a bit more today in the chat with Pranay is the verify stage. We're basically, of course, running continuous integration against your code. We're doing things like continuous delivery, continuous deployment. And under that continuous integration bucket in that verify column is where we'll talk about the execution engine, the very flexible execution engine that we built at GitLab called the GitLab Runner, and the fact that you can run that very efficiently on ARM-powered chipsets. But just really fast, I'm going to go left to right and just kind of briefly touch on the other stages. We have our manage stage, which provides you that visibility and insight, right, into how your business is performing. So we've got great metrics there on your business metrics, right there in the GitLab interface. And the plan stage, you basically have the ability to plan your projects end to end. And of course, all of this is integrated in terms of one brilliant UI. And then you have the create stage, where you're creating your source code, you do things like source code management, you have other things like code reviews and so on. And then as you can see, as you move across the rest of the quote unquote stages from a lifecycle perspective, everything that you can think about from now running your continuous integration, code checks, your continuous deployment, automation, to packaging up your code, right? And of course, you're doing security checks, you're doing automated testing as part of verified stage before you package your code. We have integrated security scanning tools, and we're actually releasing some very new cool features in 14.3. I hope you check out our 14.3 release posts around security scanning enhancements. Super excited about that. And then you get into super secure, super integrated platform. And then you get into things like, okay, now I'm releasing my code out in production, right? Continuous delivery. I can push it out to my cloud platforms. I can push it out to my on-premise platforms as well. Again, all integrated within this one ecosystem. And then you have things like configuration management, where we're doing things like, okay, knowing that Kubernetes and knowing the containers and Kubernetes as an orchestration layer is super like the du jour today, right? Everybody's like all in Kubernetes, right? Well, do you have to leave GitLab to kind of manage some of that? Can you get some of that integration within GitLab? And the answer is yes, you can. And we have Kubernetes integration with some of the really cool capabilities that have been coming out lately in terms of a Kubernetes agent, out of DevOps, which has been there for a while, and so on. So you can kind of start seeing how this all fits together. And in the last two stages, our monitor stage, where, okay, now we're in production, and the less fun stuff maybe is there. Now you're like tracking issues in production or incidents and so forth that we all deal with as part of being in the technology space. Again, you can manage all that in GitLab. And then more importantly, you can track those incidents or associate incidents and come in all the way back to the original piece of code. You can get an instant and say, oh, I'm going to open up a new merge request to fix that incident, right? And then get everything as part of one integrated lifecycle. And then finally, our defense stage. And so I know I spent a few minutes, and sorry, putting it like a little bit verbose. I'm super excited about talking about the capabilities of GitLab, but just setting the stage. And then now we're going to talk about just executing automation, executing your CI/CD jobs in GitLab and doing so efficiently. So let's jump to the next slide. Let's talk about that.
Yeah. No, before jumping, I think I second your point, and thanks for setting the stage for with DevOps and especially with GitLab, what things can we do? Not just because DevOps, when you think about it, it's not just CI/CD, not just continuous integration, continuous delivery. It's much more than that. And with these like stages breakdown, we can clearly see that there are much more to it. And DevOps is a concept, it's a practice, right? And the things that you apply to it, for example, the configuration, the Kubernetes part that you talked about, it's really critical in these days, even in dev scenarios. People are talking a lot about Kubernetes. They are integrating a lot of their applications, or rather porting all of their applications into containers and leveraging those as part of the Kubernetes cluster. And ARM supports all of that. So with GitLab and ARM, this combination that is we are talking about, it actually puts forward the point of having a complete DevOps cycle, and it's supported on ARM. So anyway, so I completely agree with that sentiment.
Oh, wow, finally somebody agrees with me. That's awesome.
Okay, so let me go to the next slide, right? So this is, AWS Graviton2, these are the EC2 instances that are powered by AWS Graviton2. These are based on the 64-bit ARM Neoverse cores that provides customers with best performance and price performance benefit over a broad spectrum of workloads with an extensive software ecosystem support, right? So it delivers a major leap in enhancements in the than the first generation of Graviton processors. And these processes are based on, like I said, it's a 7 nanometer process, which with up to 7x performance, with 4 times compute cores and 5 times memory, with respect to the first generation Graviton processors. These processors power the M6G, the general purpose instances, C6G, the compute instances, and R6G, the memory based instances that they provide up to 20% or around 20% price performance, cost benefits, and up to 40% price performance over comparable current generation x86 based instances for different, like I said, for different variety of workloads, including application servers, microservices, etc. Open source databases and some in-memory cache databases as well. So, right, and this is all based on ARM, needless to say. So that was just a general intro about this. So I'm going to go to the next slide, and we are now getting into the GitLab stuff and what we did with the performance analysis part. So before we get into that, I just want to talk about that. Why did we choose to do some performance analysis of GitLab on ARM, right? So we wanted to get into a space, and we wanted to collaborate with GitLab as ARM on deploying GitLab and GitLab Runners, both on ARM-based platforms and AWS Graviton2 instances. And Darren, do you want to comment anything on that?
Yeah.
How we got here?
Yeah, sure. Yeah, and there's such an additional context as well, is that, one of the great things, I shouldn't use the word great, but one of the interesting things about GitLab as sort of a single DevOps platform is that you as a customer can consume or gain the benefit of GitLab multiple different ways. So one is, if your organization is able to, you can simply adopt GitLab SaaS, which is our SaaS offering. So you don't necessarily have to, I need to go buy GitLab, install it myself, manage it. You just can go to a SaaS offering. However, as we all know, there are a number of different reasons, right? And depending on the kind of organization that you are, and et cetera, and security and all that good stuff, a SaaS offering, even though we all migrate into the cloud, a SaaS offering may not necessarily be the thing that works, for your organization. And so we have this concept at GitLab, I should say it's a concept. We have this other offer at GitLab called GitLab Self-Managed, where you're basically, you get the same capabilities as GitLab SaaS, but in an instance that you install, configure, and manage on your own. Now, that's kind of high level GitLab. And now we have this other little piece of software, which I'm responsible for as a PM, called GitLab Runner, which is kind of super interesting in that it was the application that was built many moons ago by the original team that was meant to, and still does obviously, enable the execution of your CI job on various compute platforms. And so it gives you the flexibility, and it works, obviously, it's very tightly integrated. It only works with GitLab. And the cool thing is, you can host a GitLab runner on most compute platforms. And what we've done over the past few years is continue to extend our support for running or hosting that runner on ARM-based instances. So if you're an ARM shop, right, and you say, well, okay, I'm super interested in GitLab, or maybe I've already adopted GitLab, but hey, can I use, is ARM and ARM64 supported? It absolutely is. And then what's happening with that, that relationship between GitLab and ARM? Well, we continue to work very closely together. And this is one of the reasons why we did this performance analysis, to kind of show the evolution of what we can do with the runner in terms of being able to execute your CI/CD jobs on ARM-based, ARM-based compute. Okay, hopefully that was helpful.
Yeah, that was, thanks for again setting up the stage for the next slides. So let me move on to the next one. So this is a high-level overview of the GitLab 10K reference architecture. Now, GitLab supports users, right, from single user to like up to 50K users. You can use the self-hosted GitLab for up to 50K users, and you can have all that good functionality that Darren just talked about in-house and deploy on your own, right? The reason for selecting 10K reference architecture was that we wanted to target mid-tier to large size organization to have a real aspect of how users interact with it and what kind of benefits would they get in terms, not just in terms of performance, but in terms of cost also, if they move or migrate their existing workloads or their existing deployments on Arm-based platforms. So for 10, for instances of GitLab with less than like 2K users, it's recommended that you use the single node GitLab deployment if you want to use a self-hosted deployment to minimize the maintenance and costs. But if you have, or organization has more than 2,000 users, then you need to scale up your environment based on how many number of users you are planning to support with the GitLab instance. Now, when you scale these components of GitLab, there are like multiple machine nodes with high availability. For each node, you do a different kind of configuration, and it's all documented really well from GitLab itself. And there are, like, while scaling, you need to understand multiple factors, right? So all of these components that you see here in the picture, they are available for Arm-based platforms like AWS Graviton2. And we kind of deployed all these components on top of the Graviton2 based instances. And the configurations of those, you can check it out, and we'll talk about it in the end of the session. But there are multiple factors that you need to consider when you go up, right? One is how does the application handle the front-end traffic, like multiple application nodes? You need that. You need an external load balancer in order to distribute the traffic across all the application nodes. And then you do a highly available multiple node setup, like I said, with external load balancer. We have Prometheus and Grafana to track the performance, or rather to see the metrics of each instance and what kind of instances you use. And all of that is handled by this 10K architecture. The one interesting thing, or there are, I would say, configuration settings that are recommended or by GitLab. And what we've employed while doing our performance testing was that we used what is called as test request per second rates. And there are different per second rates that we'll talk about. And I'll talk about that in a second. And here we also see, I have made a note that we see an up to 23% cost savings by deploying GitLab on Graviton2 based instances compared to the x86 based instances that we did. And we'll see the cost saving comparisons as well. So bear with me for 1 second. I'll just go to this next slide. And so here, this is the load generator or the performance configuration that we used. Now, the tool that we used to do the performance benchmarking of GitLab on both x86 and ARM is called GitLab Performance Tool, or GPT. Now, this is developed in-house by GitLab, and it's regularly used by them to do these reference architecture testings. And it's all public information. You can, we'll share the links at the end of the presentation, and you can go and look at it. At a high level, there are two different sets or tests that are generated called GPT. And this is, the tool itself is based on K6, the open source tool, and it provides a lot of different tests that are designed to effectively test the performance of GitLab. Now, it can be used manually and automatically. And the diagram that you see here, that's all the data that's generated through the load generator GPT is under a group named GPT, and it's split into two areas, vertical and horizontal. Now, the vertical data, this data consists of one or more large projects that are considered a good and representative size for performance testing. And for horizontal, they have like a large number of subgroups which has like small projects in each of those. So the data is divided such that you use that data and for load generation. Now, coming to that, the thing that I was talking about, the test request per second rates, Those are published by GitLab itself, and that is like 20 RPS or requests per second for per 1,000 users for an API-based testing. And we'll see what I mean by that. For the web, it's 2 RPS per 1,000 users. For Git is again 2 RPS. And for Git push, it's 0.4 RPS, requests per second. So when you do for a 10K architecture, you just multiply it with 10, and you get the data set of 200 RPS, 20, and 4 RPS for that matter. Now, in order to see that, let me go to a spreadsheet here. Hopefully this is visible enough. So these are the different tests that you'll see.
There you go.
Yeah, can you see it?
Okay, I can see it now, thanks.
All right. So these are the different tests that I'm talking about when I say what kind of RPS we do. So these are the API-based tests, the Git pull, Git push, and the web-based tests. And these are the results for x86 and ARM, and we'll talk about that in a second. The next thing that I wanted to mention is, in order to provision all this data or all this infrastructure, the components that we talked about, we use what is called as GitLab Environment Toolkit. It is again built by the quality team at GitLab, and basically we use it uses Terraform and Ansible that supports the configuration and provisioning of machines for the infrastructure and for these reference architectures. So you can use this as is with some tweaks made for each kind of architecture, and it supports deploying all reference architectures dynamically from 1K to 50K. And before we go there, I wanted to show that all of these repos are available readily. So this is the GitLab performance tool repo that you can use. And this is a public repo that you should be able to use. Oh, my bad. All right. The GitLab environment toolkit for provisioning infrastructure for the performance tooling process, right? So let me now come back to the performance or the cost benefits of it. So the spreadsheet that I showed here, these are the tests that we ran for their duration of time. And then we did some cost comparison. So we simulated monthly cost of running these tests on both x86-based and ARM-based platforms. And the interest and the results that we saw were pretty amazing. So if I click on this link, this is the x86-based, oh, my bad. This is the x86-based link. And if we go through the Amazon calculator, it shows a monthly cost of deploying these components as around like $9.2K per month. And now if I click on the ARM-based calculator, then the cost should come to 7,057. So this calculator, and we've shared it in the spreadsheet as well in the previous slide. And so you see the benefit or the cost benefit of up to like 23% cost benefits if you deploy all these components on when I say all these components, these are the components that I was talking about: external load balancing, console, Postgres, Redis, GitLab Rails, everything else. So you should be able to deploy these on x86 and ARM and see the benefits yourselves.
That's super interesting.
Darren,
yes.
Do you want to comment anything here?
No, I was just saying that's actually super interesting. It's actually it's really a very kind of sort of, the message kind of resonates with me looking at it this way, because as your self-managed customer thinking about potential deployment scenarios, knowing that you have a choice in terms of compute architecture, and then the choice of compute architecture can make a material change or impact positively in terms of your your monthly costs, is really something to think about. That's super interesting.
Okay, so this was the GitLab 10K architecture performance benchmarking that we did. Now we'll just make a segue into the GitLab Runner performance benchmarking. Now, before I go into this, Darren, do you want to provide any comments here?
Yeah. So let me give just a little bit of color. So what Panay just kind of went through in detail was like this, the GitLab instance, setting up, again, if you're running and hosting and configuring, the self-managed instance of GitLab, that's all of the components and the considerations that you would have to take into, especially if you're going to be hosting it on something like AWS, right? So you've got the GitLab instance, assume you've got it configured and your groups and your users and your projects are going, and now you're into, okay, great. Darren and Pranay, now I actually want to go build some CI jobs. I want to go check in some code into one of my project repos, or my developers checking some code into one of my project repos. And I want to have GitLab do its, its CI magic. And that's one of the powerful things about GitLab is that CI/CD engine is built into what has been built into GitLab for almost day one, right? So it's pretty fully integrated. And so in order for that to happen as a self-managed user, if you will, of GitLab, the other piece of component you have to deploy, in addition to Postgres and all the interesting things on the self-managed, on the instance side, is your GitLab runner. And like Penny was talking about earlier, we chose a 10K reference architecture, right? So 10,000 users. So if you happen to be an organization on that scale, let's say 10,000 users, and then just to say a significant percentage, let's assume for a moment, a significant percentage of that 10K, that 10K number is actually checking in merge requests, doing some kind of active software development. So if you're really large, maybe shop like Arm, you probably are doing a bunch of code check-ins on a daily, weekly, monthly basis. Now you have to start actually running those CI jobs, and that's where the runner comes in. Now, the cool thing about the runner is that it's super flexible, right? You can choose to deploy one runner executable on one virtual machine or bare metal server, right? And specifically, we're talking about Graviton today, an Arm, right? And have that one runner manage hundreds and thousands of CI jobs in GitLab, right? And then one thing I want to mention really briefly about the runner that we sometimes don't highlight in our docs is that the runner is and GitLab together, I should say GitLab first, is a highly parallelized execution platform. And by that, I mean, and I'll tie this in, hopefully I'll tie this all back into the slide in a second. By that, I mean, if you go into GitLab today and you open up a very simple project in GitLab, and let's say you've got multiple pipeline stages in that project. And let's just say, for example, under your test stage, you've got parallel testing jobs. And maybe like one job is doing a vulnerability scan, and maybe another job is just doing some linting, but you're running all of those in parallel, right? Within your test stage in GitLab. And GitLab makes it super easy for you to set up that construct within 2 clicks or within some simple code check-in. You've got this really cool parallel kind of thing happening on, let's say, your testing stage. But what's really super interesting about GitLab is that all of those pipeline jobs can run in parallel. And the GitLab scheduling engine that's happening on the GitLab instance itself is scheduling all of those jobs to run in parallel, which is pretty cool because you don't have to wait. If you have, like, say, a long tree of testing jobs, you don't have to wait for each of those jobs to execute sequentially or synchronously, right? Before to get work done, to get your code shipped out faster. But then as each of those jobs are executing, what's happening? Well, guess what? The little runner agent that Pranay is showing here on the right-hand side, which in this case is running on that VPC in AWS, it's actually spinning up those workers for you to execute those jobs. And we have a number of different mechanisms within the runner, by the way, that can allow you to easily scale up to handle hundreds and thousands, maybe millions of jobs in your environment. And so that small executable is really the little engine that's executing whatever CI/CD workload or job you send at it. And so understanding the ability to host that runner on different compute platforms, understanding the ability for you to auto scale that runner on various public cloud compute platforms is super important. And then one other thing to kind of call out as well, customers usually come to us and say, hey, well, what size, if I'm on AWS, for example, because we have AWS side, say I'm on AWS, like what size should I use for my runner, right? What size compute should I use and so on. right? And today, I mean, obviously in this presentation, we've kind of gone into a specific size VM that's based on the ARM, but we typically tell customers, it kind of depends, right? And so we typically say, start small, use the built-in metrics to measure what the workloads are doing, because the runner will handle it. The runner is pretty efficient. And then if you find out over time that a specific job should probably go through faster, and then maybe it's compute bound, if you will, or maybe memory bound, then you make the adjustment to say, let's increase. And so long story short, it's a very powerful piece of software, and I think made even more interesting and flexible now that you can run it on ARM on AWS. And so some of the metrics that Renee is going to jump into will hopefully kind of bear that out.
Yeah,
so I don't know if that was a stage you were hoping for, but I kind of went all over the place.
It was definitely, no, it definitely was. And I think now I'm not going to go into much details of what runner, as you've already set that up. So I'll directly jump into the schematics of it. So here, as you can see, the GitLab runner, or the self-hosted runner, is supported on ARM since GitLab 12.6. And what we essentially did in this performance study is we used two different instances of GitLab runner. One was deployed on an x86 based EC2 instance. To be exact, it was on the large and extra large instances. And I'll talk about, I'll cue into what Darren was talking about. There is no one size fits all. You need to gauge that. So we did that. And what we did was we were collecting the metrics from a Prometheus and Grafana instance deployed on the same VPC. And basically what we measured was the build speed. Now, build speed of what? It was, again, a repo that builds a Linux kernel. And building a Linux kernel takes a while. And we measured the build speed of that for x86 and the ARM-based AWS Graviton2 based runner. So we measured the build speed of on both for the Linux kernel, and we saw a 36% performance gain on M6G instances, the general purpose Graviton2 instances, which completed the task in like 5 minutes and 47 seconds, pretty quick, compared to the M5 instances, which was like around 7 minutes and 53 seconds. So the build speed was the key factor, because you want your code, if you are executing jobs that has a larger code base and you're compiling a lot of different things at a time, speed is something you care about. And in addition to that, the cost benefits of it. But speed is something you care about. And we thought that that is an important metric to be measured while comparing these two different set of architectures. And like I said, all of these components and workloads are supported on Graviton. And that way you directly like jump into deploying these components for these different architectures. Now, in reference to what Darren mentioned, we kept the CPU utilization on both M6G and M5 instances up to 100%. We wanted to stretch it out to see what kind of performance we get with that. So both the runners would stretch out to 100% CPU utilization. And based on that, we decided the size and where we want to do the comparison and other stuff. And as you can see in the charts, we achieved 100% utilization for both types of instances per node and the CPU utilization as well. So with that, I think we are towards the end of our presentation. Let me go to the conclusion slide. So I'll just start, and I'll let Darren also have his thoughts in here. So what we'd like to say in conclusion is that you can have up to like 30%, 36% gain that we saw in terms of performance for GitLab runners. And that's just a key metric, of course, with different data sets, different sizes. The parameters are different and you'll see some different results, but this is a key metric that we wanted to measure, and you can see the benefit of it. And of course, you see up to 23% like cost benefits when you move your entire GitLab architecture for up to 10K users to an ARM-based Graviton2 instance, or the set of Graviton2 instances. And yeah, so the savings can be significant, and I'll let Darren talk about the next part of it.
Yeah, that's true. And the cost savings is actually really, really interesting. And I know we're talking about 23% cost savings, and that is a lot. And that's actually significant. And so, one lens we should certainly be aware of. And one lens the folks taking a look at this should also be aware of, because as you plan out, again, assuming you're going to be heading down this path where you're needing to host your own, GitLab environments and so on, planning out how you're going to scale that environment over time, especially if you're a larger organization, you're going to be scaling up to the size that some of the size that we're talking about today, having that kind of forecast in terms of what your cost structure will be like. Because as you get larger, obviously a 23% cost savings becomes magnified. You know what I mean? That's certainly a very interesting thing to look at. And I think the other thing I want to kind of go back, talk about as well really fast in closing. Pranay was in the last time was talking about the speed improvements, right? In terms of being able, we ran on compute platform A on AWS compared to the Arm Graviton compute architecture on AWS, the times that it took for us to run through the compilation of that Linux kernel. And I believe it was roughly 2 minutes or so difference, and keep me honest. That's kind of interesting to think about. And at the micro level, the 2 minutes difference may not seem, oh, it's only 2 minutes. But then we kind of start stepping back. Again, if you are the DevOps practitioner for your organization, or the lead, or the chief technology officer, as you're thinking about everything related to DevOps, and some of the key terms that are out there today, DORA metrics, and improving mean time to recovery, improving lead time for changes, that 2 minutes, depending on how many hundreds of thousands, or maybe even millions of jobs you might be executing as part of your CI/CD pipelines, right, on a monthly basis, it adds up. And so by us, kind of what we're trying, I guess we're trying to get across here in this presentation, you've got a very flexible piece of software with GitLab, and now the GitLab Runner. With the GitLab Runner, a lightweight piece of software, and one that supports multiple compute architectures, specifically Arm. And so you can scale up very efficiently, and you can actually realize not only these time gains, which when multiplied over a larger universe of jobs, could really make a significant impact on your business in terms of both your lead time for changes, and then potentially over time on your cost structure as well. I think it's really a really interesting kind of thing to think about as you plan out the next level of your DevOps maturity.
Cool, thank you. So we are on the next slide. So here are some links for you to peruse through. We published a blog on the same case study. That you can check out. Feel free to check out the GitLab 10K reference architecture. It has some great material in it. The GitLab Runner documentation and the stress repo as well that we use to build the Linux kernel to test out the build speeds between GitLab Runner. Do check out the Arm Neoverse page with a lot of good information on what Arm Neoverse is, about N1 and the other families of the architecture. And then we also have a page, sorry, my page keeps going back to it. We also have a page on the Arm plus AWS collaboration. Feel free to check that out too. All right, and then finally, we welcome your feedback. For any questions or anything, feel free to reach out at infra-solutions.eng@arm.com. We'll be happy to hear any questions, any thoughts that you have, or if you want to collaborate. And that's about it. So from my end, thank you. Darren, any last thoughts that you want to talk about?
From my end, this was awesome. Pranay, thanks a bunch for collaborating and having us work very closely with you and the rest of the Arm team on putting together this very interesting study. It was super interesting. I hope the folks that are looking at it got a lot of the value out of it. I'm just going to say in passing, danke. I hope I pronounced that right. I've always been wanting to say that in a video for like all these months. I've been looking at all these great movies on Netflix. So hopefully I got that right.
All right. Thanks, everyone. Hope you had a wonderful conference ahead. And thank you for listening in.
Cheers.
Take care.
Thank you so much. Talk to you soon.
Thank you. Bye-bye.